So let's say Boston Scientific calls you, maybe they already have, and they said, okay, we've got the exoskeleton ready. We just need the right BCI partner.
Well, there are a lot of people actually a lot of companies that are developing exoskeletons, most of them are startups, have reached out and said, hey, could we use your BCI to control our exoskeleton? And what I've told them is, if you can direct the exoskeleton to do the things that you want it to do when it's controlled by the BCI, then it's ready for BCI control. So simpler examples, I'll give the hand example. Let's say that you have a robotic hand. And if you can put sensors on my hand and detect the location of my hand, and as I move it and your camera looks at my hand, you can get your robotic hand to do the same thing, then you're pretty much ready to plug into a BCI. Because BCI right now is, if you put a BCI in the hand knob, it can measure when people are trying to move their fingers. As we have BCIs that can be placed more places in the motor strip and record more areas of the brain that are involved in more parts of movement, it's inevitable that we will be able to put enough BCIs across the motor strip to reconstruct someone's intended hand and arm function. And therefore, we can take that same data and control our robotic arm. I think what is unrealistic right now to expect BCI to do is, if you have a robotic arm or you have an exoskeleton system that you want to walk, but you haven't figured out the control yet, like you haven't done your homework, our robot, like when we try to tell it what to do, it kind of like still stumbles on stairs and like falls down. It's not realistic to think that you're going to rely on the BCI to fix the problems in your system.
Got it.
But pretty much if you have a robotic arm that can do what it's supposed to do, or you have an exoskeleton, like lower limb prosthesis system that can walk upstairs and like navigate complex terrain, then yeah, if you plug the BCI into it, the BCI will be probably better than whatever current input device you're using.
And how far away are we at Paradromics from where we have the ability to do that from a data rate perspective? And
any exoskeleton that exists today that's being used with, let's say, joystick or like a series of buttons, would be better controlled by the device that's sitting on our desk right now. Like, I actually think right now the work is probably on the companies that are building the exoskeletons and the robotic limbs.
They're the limiting factor.
I think so. Not because it's fundamentally limiting. Like, I think there are a lot of really advanced robotic companies right now that could execute on those things. I mean, look at the things that Boston Dynamics is doing, right? If you plug a BCI into like the Boston Dynamics robot, you can get it to do like wild, crazy things. And so it's just a matter of getting that same level of engineering at the prosthetics and exoskeleton companies.
Got it.
But of course, they have other constraints, right? Like, there's no one inside of the Boston Dynamics robot when it does like a backflip. And if the Boston Dynamics robot, does a backflip and then like falls down the stairs, there's no consequence to that. So there are different constraints, and there's like a higher bar that the exoskeleton companies are going to have to hit. But I still fundamentally think that like once they're properly resourced and they get going, yeah, they could build the kinds of things we want.